First thing I want to do is just sketch it out. So important thing whenever we make these sketches that angle A, side A, or angle A, alpha and side alpha, they always have to be opposite each other. So I have side A, side B, angle C. So I'm just going to draw any old triangle here. I'm going to call this angle C here. So that's my 40.1, 40.1. And then side C has to be over there. And then the order of the others doesn't matter. So let's say if that's C, maybe I'll put B up here. So this would be side B. And then this would be A over here. And so this would be side A. So I'm given side A is 2.16 and side B is 3.44. So just a rough sketch to put things in perspective. And so here, since I don't have angle A or angle B, I can't use the law of sines. I don't have enough information, but I do have two sides with the angle between them, and that's what the law of cosines is designed to work with. So the law of cosines is related to an angle and a side opposite it. So given this angle right here, I would write the law of sines as c squared, law of cosines equals a squared plus b squared. So it's kind of like the Pythagorean theorem, but we got this little tweak, minus 2ab times the cosine of the angle between A and B, which is that 40.1 degrees. And then we plug in the values of A and B. So we get 2.16 squared plus 3.44 squared minus 2 times 2.16 times 3.14, nope, 3.44 times cosine of 40.1 degrees. And I highly recommend you write this down before you hit your calculator. I'm looking for C, so I want the square root of all of that. And so once I get that down, I'll go to my calculator. And the other thing I want to do is I just want to make a rough sketch of that. So I'm going to make a rough sketch of that down here and see how my calculation compares to that. Let's see, we need a 40-degree angle. So from here, 45 is the main diagonals there. So 40 is just a little bit lower. So I'm going to guess 40 is around there-ish. And then from there, I have to measure off my 3.44 and my 2.61. So I tried to make, to the best of my ability with this pen, 40.1 degrees. And then let's see, we have to decide what 3.44 and 2.16 looks like. So maybe I'll go out, how about 1, 2, 3, 4, that can be 1. 1, 2, 3, 4, that can be 2. 1, 2, 3, 4, that can be 3. So 3.5 would be here, 3.2, 3.44 maybe is about here-ish. And then I have to estimate up this way, that same amount. So that distance 1 up here, I think that would be about here-ish. And maybe this is about 2. 3 would be out here, 2.5. 2.5, so maybe 2.1's around right here, 2.16 is my rough guess there without a ruler. And so then my triangle would be this right here. So that's what this triangle should look like. Rough sketch, not quite as rough as the one above. Otherwise, whip out the calculator, see what we get for that length. And I can show you how to also draw this on something like Geogebra. So I'm going to go right to Geogebra. There's the graphing calculator and the geometry one. They both do the same things, but the buttons are a little bit different. I like the geometry one lately. And I'll use these tools in a minute. For now, I'm just going to go to algebra, which is basically the graphing calculator. And so I want that square root of 2.16 squared minus 3.44 squared. And I'll have to double check, but minus plus, sorry. My recollection is GeoGebra defaults to degree mode most of the time. and then minus 2 times each of those, and then times the cosine, oops, times, let's widen this a little bit. And they have a toolbar down here, so I can go grab the cosine, and they also have a degree button, which I like. And what was mine? 40.1. I'm going to make sure it's degrees by doing that. And it comes up with a calculation of about 2.3 on that. So let's make sure I'm out of there. Yeah, so it says it's about 2.3. So does that seem realistic based on the picture I drew? Let's look back. Okay, so the biggest angle is up here at the top. And, oh, I connected that to the wrong spot. Let's undo that. I need to connect that to 3.44. That's better. Okay. So the biggest angle is clearly up here, right? So that should go with the biggest side, 3.44. This angle right here, that looks smaller than the 40.1 to me if my picture is accurate, and I think it's reasonable. So this should be the smallest side, so this should be the middle side, and we just calculated that this right here is about 2.3. And I just want to double check the decimals there on that one. So I think side C here is equal to 2.3, and that seems reasonable in the picture. It should be the middle side based on these other angles. Did I type things right? 2.16, 3.14, 3.44, 40.01. Let's see. Good, 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 good. And then under the config here, I can do things like under settings, I can adjust the number of decimals somewhere. Let's see here. 1 decimal place. Yeah, let's go out to 5 decimal places. 2.26536. All right. Now, if I actually wanted to draw that to double check it, I can do that. So there's another video I posted earlier about that. So I just want to show how to do that here. So I need a baseline, and I can measure out those lengths that I have. So I'm just going to plot a couple of lines here. Let's use the line tool. So I'm going to start at the origin, and I'm just going to put out here another point for now to put that line. And then from there, I'm going to draw my angle, and then I'll mark off those 2 sides. So more, I want an angle of a given size. And it says to select a leg point and then a vertex, then enter the side. So here's my leg. I'm going to have the vertex at the origin. Counterclockwise, degrees 40.1. And so what it will do is it'll just kind of trace a circle and put a dot on the circle at 40.1 degrees counterclockwise. All right, so there's that dot right there. Come on, get out of the way, tools. Okay, fine, don't. Ah. Oh, no, stop it. Sorry, I'm having technical difficulties. Okay, so let's move the screen. So then we're going to draw a line out connecting that and mark our sides. So I'm just going to draw another line here. And there's many ways to mark where 3.44 is and where 2.16 is. I found the easiest way is with a circle with a radius. So there's circle with center. I want circle with radius right here. And so then what I do is kind of like using a compass, is I just say, hey, from that point, make a radius of 3.44. So there's going to be a point here. Let's mark that. Let's see, where's the intersect? Or intersect. So I can mark that intersection. So there's one of my points. And then the other point, we just do that again with the 2.16. So circle with center, radius, 2.16. So it'll just draw a little bit more accurate picture than I could have. So then I'm going to mark that one up here. And where's my intersect? There it is, points. And so now I have my triangle. Now the letters are different. That's no big deal. Just keep that in mind. And so there's a tool to draw a triangle. Oh, there it is, polygon. So my triangle is this one right here. Boom, 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 and back to where I started. And then I can check by finding out the length of that line segment right there that we just did. And down here, there is a measure, distance or length. And you can either select 2 points or the line segment or the polygon. So I'm going to select that line segment right there. And it says it should be 2.26536, which is what my algebra told me also. And then I can also have it measure those angles. So like if I needed that angle up at the top there, which I think I was calling angle B in my picture, I would just use the measure angle tool. And you can either select 3 points or 2 lines. If you do 3 points, the middle point has to be the vertex of the angle. So I think if I go around in this direction, I can get that angle up there. So once I've drawn those, and again, the way to draw them is to get an angle, you have to have a line to work off of and measure your angle of a given size. And then to get distances on lines, use the circle of a given radius. And with those 2 tools and the intersect tool, you can build any circle based on information like that right there.